process of electrolysis. Activity. First, let us take a solution of 1 gram copper sulfate in 50 ml water in a 100 ml capacity beaker. Let us use a thick plate of copper as anode and connect it to the positive terminal of the battery. Use a carbon rod as cathode and connect it to the negative terminal of the battery. Now pass an electric current through the circuit for some time. What do you observe? We observe that copper starts depositing on the portion of the cathode immersed in the solution. How does this happen? Come, let us understand. When an electric current flows through the circuit, copper sulfate in the aqueous solution gets ionized into copper ions and sulfate ions. The cations, that is copper ions in the solution, get attracted towards the negative electrode, that is the cathode. These copper ions combine with the electrons coming out from the cathode, forming copper atoms. But have you noticed that the color of the solution has remained the same even after the copper ions in the solution were used up? This is because while the electric current was on, electrons were removed from the copper atoms of the anode and sent to the battery. As a result, copper ions were formed on the anode, which then entered the solution. In this way, decomposition of the solute in the solution took place due to the electric current. This is called electrolysis. The electrolysis process involves two parts. One is the reaction at the cathode. It is represented as copper ion plus 2 electrons give copper atom, while the other is the reaction at the anode. It is represented as copper atom gives copper ion and 2 electrons. Always remember, for electrolysis to take place, it is necessary for the liquid or the solution to have a large number of dissociated ions. Therefore, substances which undergo dissociation to a great extent in the liquid state or a solution are called electrolytes. Salts, strong acids and strong bases are electrolytes. Their solutions have high electrical conductivity. We can also say that electrolytes are good conductors of electricity in their liquid or solution state.